We're really excited to have you all here for our virtual reality with eye tracking and biofeedback presentation. We're going to be showing some cool tools that we use in-house to make eye tracking with virtual reality very easy for folks, and also how that can connect to a biofeedback device, so you can get a really cool, really comprehensive view of your subjects when you're putting them into a visual stimulus situation using virtual reality. So this is part and parcel with our participation in the virtual neuroscience conference. So hello to all the folks who are joining us from Neuroscience. We've also got folks who are coming in through just our kind of normal email newsletter channels as well. So we're really excited to have you all here. I'm going to jump in and just kind of talk about who's going to be presenting today. So my name is Dan. I've been with WorldViz for 6 years now. I'm the head of sales for Americas. We'll also be having Andy Beal, our chief scientist, coming and telling us a lot about some of the core principles of why virtual reality is an effective research tool in neuroscience in particular. And then we'll have Seda Rabouti, who's our product manager for the Vizard software, which is our kind of core flagship product here at WorldViz. And he'll be giving us a nice demo of some new software that we've been putting together that really makes it very easy to do eye tracking research. So without further ado, let's jump in. The first things we'll cover is just a little introduction to WorldViz, and then we'll have the section from Andy that's the deep dive on the neuroscience intro. After that, we're going to be doing just a really quick overview of different hardware tools. So, you know, what are the various VR headsets that have eye tracking built in that are available right now, and also just a quick intro to the kinds of software tools that we're using for creating our virtual environments, creating our stimulus, and also gathering eye tracking data. I'll also talk really briefly there about biofeedback devices from a partner company of ours, Biopack. And after that, it's just going to be a nice kind of deep dive demo with Seda. This is going to be a fairly short webinar, so we're thinking about 30 to 35 minutes in total runtime. And then after that, we're going to have a live Q&A. So you'll see that there is a nice little questions section here in your panel as an attendee. And so you can submit a question at any time there, and we'll be able to respond to that in detail at the very end. So we've actually got some other folks in the background who are helping us out, copying those questions in. So just as a heads up, everybody's muted. And we are also going to be making a recording of this webinar, and it's going to be posted to our YouTube channel along with our other past webinars. So if you haven't had a chance to check those out before, definitely invite you to come and take a look at those. So without further ado, just a little bit about WorldViz. You know, we've been in the professional enterprise virtual reality space for almost 20 years now. So we actually came out of a psychology research lab at UC Santa Barbara. And the experience that we had there was really kind of driven by Andy and his work at MIT as well. And they were creating some of the very first functional VR systems in the kind of sense that we would think of them today. These were very complex systems that required a lot of different pieces of hardware, like external motion capture and external inertial measurement devices and things like that, to create you know, a VR experience. But it was really kind of laying the groundwork for the virtual reality world that we know today from the big players like Oculus and HTC. So throughout that entire 20-year history, we've really focused on our kind of core academic customer group. And a big part of that is our Vizard software, which I'll talk about just a little bit, but it's really geared towards researchers as opposed to kind of game development. And we've also worked a lot in the kind of enterprise space as well, working with customers on things like aerospace engineering projects for NASA, and then even some more like marketing-based projects for things like Nokia and Sleep Number. So we've definitely seen a lot of use cases over the years, but really kind of very much focused on our kind of core academic use case throughout all that time as well. So the first thing that we wanted to do is actually just get a sense from our audience about what your experience is with eye tracking. So I'm going to launch that poll now. And if you all don't mind participating, that would be great, because it really gives us an idea of how we should be gearing our presentation to you as much as we can, just to have an idea of what your experience level is. So I'll give it just a second longer here. It looks like we've got some folks who are new to the VR and eye tracking world, which is great. Awesome. So we've got about 80% participation right now, which is awesome. So thank you all so much for participating in this poll. I'm going to go ahead and close that now. And now we can actually share the results. So as you can see, we've got all over the board here, which is great. 25% of you already use a VR headset-based eye tracker, which is awesome. Really excited to introduce the folks who haven't had much experience with this technology before to this as well. And like I said, throughout this whole process, if there's any questions that you guys have, go ahead and drop them into that question slot, and we'll be happy to answer them in detail at the end. So what I'm going to do now is I'm actually going to hand it over to my colleague Andy. And Andy is going to give us a nice introduction to VR research and neuroscience. So Andy, I'm handing it over to you now.
Great to be with everyone here at Neuroscience, and I'm excited to give a quick rundown on some of my experience using VR for basic research over a course of several decades. Dan mentioned the company's been involved in VR for 20 years, and I go back another 10, creating VR hardware and software. And I want to start with, like, in some sense, everybody's mind is like the most basic aspect of VR, and that's what you get to see, and that's the display. In many ways, the goal here in VR is to create the ultimate display, and it unlocks just a whole world of possibilities in research. And by display, we typically mean either projection or head-mounted, and head-mounted is the most common. But you should be aware that projection displays are actually quite commonplace, both in research and in commercial uses, involving projectors for single screen, multi-screen, curved screen projection. And they're common in flight simulators and also common in fMRI systems because it's most often difficult to get a head-mount display inside of a fMRI. So it doesn't really matter how you want to get the light into the eye, but today, as mentioned by Dan, some of the big industrial players like Facebook, combined with Oculus, HTC, other companies are really pioneering essentially professional quality technology packaged in a consumer sort of box. And that's the head-mount displays that we're seeing prevalent today. And they are just really, in many ways, incredible of what they're able to do. Now, those of you new to VR, you've no doubt heard about head tracking. Really, the display and head tracking go hand in hand. You can't really have VR without both of those there. And together, they create the kind of magical illusion of presence, of being in another environment, being somewhere else. And each of those needs to have certain requirements on their capabilities to really cast that presence or create the illusion that you're somewhere else. With the projection displays, it's kind of coming down to the quality of the display, the number of pixels. With the head tracking, it really comes down to the latency. So when you rotate your head, is there any perceptible lag with those movements? And even if it's not overtly perceptible, it may lead to motion sickness over the course of time if you're not being careful. That said, the technologies available today in these consumer devices have such low latency that unless you're doing something really just overtly wrong on the software side, you're not going to be making people sick, and you're getting to the levels of lag that are really really imperceptible even at the sensory level. Binocular cues are one of the sort of fancy terms that we can use in visual displays. Stereoscopic cues, those are really part of every type of visual display we're looking at here. But I can compare those to binocular oral displays and other sensory modalities. So VR is often mistakenly just combined or equated with visual. It need not be. And there's actually some very good work, very good technologies, nowhere near as consumerized as the Oculus headsets, but technologies that provide a 3D sort of solid surround of acoustic cues. And those can be used really effectively as a basic research mechanism. Now, an area that is still rich with sort of unanswered questions, in my opinion, is how to create highly naturalistic interaction. And we're really at the bleeding edge of utilizing both gloves or machine vision aided capabilities to see a user's hands and understand what they're grasping, what they're pointing at. This is, like I said, really bleeding edge area. Most often in successful research that we've been engaged with, you're using kind of older standards of button presses, something that's reliable, something that's not going to add variability or uncertainty to your paradigm. I hate to talk about VR without mentioning social interaction, and this is an area that's really dear to our company's core, and that's making technologies that can connect people. And we see that as kind of one of our areas of passion, one of our areas that really will unlock many other areas of research. And that's if you have not experienced connectedness in a virtual reality display with a live other who's geographically at another location, you need to try a demo that provides that. And you'll be amazed at how sort of tight and realistic that sense of being with that other is. So the whole sense of physical presence you gain with virtual reality with a good simulation, that is a whole nother aspect when it's a social reality that you can convey there. This term ecological validity, it's been used throughout sort of psychology at least, and I think it applies to many domains. And I'll just show a graphic of this. And in sort of traditional days of creating methods for testing human subjects in your traditional sort of psychology lab, we operated along kind of a very linear trade-off function, what I've labeled here as traditional methods. And you can have, under this sort of view, you can have very high experimental control, such as the tachistoscopic presentation point that I have on this graph, but you sacrifice ecological validity. That type of display is much like when you go to an optometrist and they're flashing things in front of your eyes. You know, feels anything but ecologically real. Versus with traditional methods, if you wanted to study driving behavior, at some point you'd have to hop in a real car, use some video cameras, and let somebody drive through a downtown street. Obviously, the ecological validity is high, but your experimental control is out the window because you're on a real street with real other drivers and there's no control. Computer graphics and eventually virtual displays, and today I would argue we have expanded the operating characteristics of these methodologies into a way that really is giving us the best of both worlds. It's giving us extremely high experimental control and at the same time, extremely tight and realistic ecological validity. A really neat sort of side benefit of using VR for experiments is increased power, statistical power. You are eliminating a lot of normal sources of just noise in your experiment if you're trying to test something that has a richness or ecological validity. Even social interaction studies that I've seen have gained statistical power by employing virtual agents and virtual avatars that can reduce the variability you'd get from just having to involve real life human confederates. Impossible manipulations is what I refer to as breaking reality, and we call virtual reality an endeavor to mimic the real world as best as possible. But many times, and I've seen some incredibly creative uses of VR, where you realize that you're not tied to the laws of physics. You can actually create a display, a simulation that manipulates variables that you would never experience in the real world, or sometimes even just trying to manipulate a variable in a certain way would be prohibitively expensive or ridiculously dangerous. And so VR is excellent for breaking out of the mold of what we experience on a day-to-day basis. And last, my lead in sort of to the remainder of our webinar discussion here, and that's the data sources that you can get from VR. Inherent in the tracking, the head tracking, is incredibly rich in low noise data about where the user's head is pointed at any given time. Most of these displays are capturing the data on the order of 90 hertz. So you're knowing exactly where the person is, where their field of regard is pointed, and where their hands are. All that can be streamed to data files for all sorts of interesting analyses. And what's Dan and Seda are going to unpack further is several of the modern displays have high quality eye trackers built into them, so that there not only do you get the head field of regard, but you get the exact location of where each eye and where the eye convergence is occurring in real time, sampled in real time for real time use, or sampled and recorded at, say, 90 hertz or better. All right, thank you, Dan. I'll pass control back to you.
Awesome. Yeah, thanks, Andy. Perfect. So you guys should be able to see me again and see my screen. Thanks, Andy, for the awesome kind of overview of why VR is such a great tool for research, and also kind of where we are today. And obviously the kind of world of VR has been changing quite a bit in the last 4 or 5 years since the sort of advent of consumer virtual reality. But there's some really cool sort of new displays and new pieces of technology that have been coming out just in the last year that have made it really accessible for researchers and professionals to start taking advantage of some of these more advanced data collection techniques. So these are just a sampling of the main VR headsets with eye tracking that we work with. The kind of price comparison to this from like 3 or 4 years ago is far different than what we've been looking at. We're actually pretty excited, and Sato is going to be showing the StarVR One here today as part of the demo. And the really cool thing about this, you can see the shape. This isn't to scale, but it's actually very kind of wide, but still light and comfortable. And it's giving you a 210-degree field of view. So there's, between resolution and field of view, there's definitely a lot of work going into making these displays as immersive and realistic as possible, both for consumers, but also for researchers as well. And the StarVR One is definitely focused more on the kind of enterprise and research-based use cases. We're really excited because we're actually going to be able to make this available to customers in North America and South America for the first time, because previously it only been available in the Asia Pacific markets. So if you're interested in getting one of these StarVR One headsets, let us know, and we can help arrange that. On the other side is the kind of more traditional VR eye tracking folks, which is Tobii, who we've been working with for many years. And Tobii actually licensed their technology to HTC, and they have gone ahead and put the Tobii eye tracking technology in sort of a mass market version of that eye tracking technology into their Vive Pro Eye, which is sort of their latest version of the HTC Vive series. And what's great about this is that, it's really accessible price point wise for folks to actually, finally get their hands on an eye tracking headset. So, it's definitely kind of become a very popular tool and something that we love to see folks embracing both on the business and on the research side. And then the final one that I'll mention is Pupil Labs, which is another one that we've worked with for a number of years. And what's cool about the Pupil Labs, you can actually see it down here, is you can add it into an existing VR headset. It doesn't work with all headsets because you need a certain amount of space within the actual compartment to fit the device. But if you've already got a VR headset and you're hoping to have some high frame rate capture out of it, the Pupil Labs is a great solution for that because you can just add it onto your existing headset. So that's just a quick look at some of the VR headsets. This is by no means exhaustive of all the different options out there, but just wanted to kind of give you guys an idea of what we're looking at right now. I'm going to talk really briefly about the software because this is more of Sato's domain and what he'll be talking about in more detail, but just to give you an idea of where we're coming from. We use a tool that we maintain in-house called Vizard. We actually just released Vizard 7 in December of 2020. So we're really excited about Vizard 7 because it actually includes support for the latest version of Python. Everything is Python based in Vizard. So it makes it very easy to pull in different Python libraries, connecting to things like MATLAB. So as a data collection tool and analysis, and for folks who are familiar with Python, which many in the scientific community are, it's a really quick adoption. The other cool thing about Vizard is that it actually has a lot of features that are built in that are GUI based. So it's exclusively focused on virtual reality and really is just working in the Windows based paradigm of virtual reality. So Windows based headsets. And it also is connecting to just a huge array, over 200 different devices we have native support for. And we actually have a visual configuration tool where you can put together like a biofeedback and a motion capture system and an eye tracking device. And all of this is visually configured so that you have this very esoteric and very kind of complex hardware setup that's all of a sudden very simply integrated into one space. So you can just focus on your stimulus presentation, and the data collection is taken care of in the back as well. So that's, you know, just the kind of quick idea of what Vizard's for and who it's aimed towards. More recently, we've actually been working on another thing, an add-on for Vizard, which is our eye tracking analytics lab. And that's what Sato's going to be showing as an actual alpha version of the latest update to our eye tracking analytics lab. And previously, the eye tracking analytics lab is giving you a really kind of nice code base that you can manipulate, you know, add your own pieces to get just an out-of-the-box working eye tracking experiment with almost minimal setup. And what we're actually going to be including in the next version of this, which will probably be released in the next couple months or so, is a full GUI-based editor. So Sato's going to be showing an alpha version of that, and that's going to make it even easier for folks who, you know, don't really want to get involved with code but want to start getting eye tracking data out of a virtual environment very quickly. That's going to be a lot easier for you now. So if anybody out there who's watching this webinar is interested in becoming a beta tester of our eye tracking analytics add-on version 2.0, reach out to us, you know, send us an email, sales@worldviz.com, and we'll be able to, you know, set you up with a beta as that becomes available. So the last thing I'm going to talk about just briefly is a partner company of ours, which is Biopack. And Sato's going to be showing how the Vizard software connects to the Biopack physiological data collection tools through their Acknowledge software. And this is a combination, kind of a winning combination that we're seeing become really popular in the VR research space, which is, you know, an out-of-the-box eye tracking setup with your psychophysio data collection, working in conjunction to create just a comprehensive view of what your subject's experience is as they're going through your virtual environment. So this is just a quick list of some of the things that Biopack is offering, and this is connecting directly into our Vizard software, and they can actually feed backwards and forwards into each other as well. So, for example, one of our very popular demos, which you can download from our website, is called the Walk the Plank demo, and it's a very simple fear of height stimulus, where a participant will be raised up on a platform. And if you've ever seen us at Neuroscience, we're always showing this demo because it gets a lot of people excited and the crowds come because they want to jump off the virtual cliff, so to speak. And it's a very realistic experience. So if you haven't tried it before, I definitely encourage you to go download that from our website. But the cool thing is when you connect it to a Biopack device, you can actually see the user's heart rate spike when we lift the platform. And if you have a scenario where you want to actually moderate that experience, if a participant's heart rate, let's just say, goes above like 130 BPM, you can actually have it automatically feed back into the visit program to lower that height. So that's just an example of some of the really kind of cool configurations that we can do just by combining all these different sensor data, and how easy that is with the software that we use. So to give us a little bit more of an idea of what that looks like, I'm going to go ahead and hand this over to my colleague Sato now. And Sato is going to give us a nice demo using the StarVR headset and our new eye tracking analytics lab. So go ahead. I'm going to go ahead and make you presenter here, Sato. Hand it over to you.
Okay, thanks, Dan. I think you need to close your webcam now. Okay, so as Dan mentioned, I'm just going to show just a kind of quick overview of our VR eye tracking analytics lab and how you can build a scene basically using your own environment, your own models and objects, and that could be 3D models or 360 videos. Just running a basic experiment, and then how you can then afterwards analyze that so you can replay the session in 3D, view a video recording, or view various eye tracking metrics that are saved to a file, or you can view those also in the replay mode. And so for this demo, I'm showing it with the StarVR One headset. So this has that 210-degree field of view. It has the built-in eye tracking from Tobii. It also has automatic IPD adjustment. So using the eye tracking, it'll automatically adjust the IPD for you. And so first, I'm just going to show you just building a scene, as I said, with your own models. And those models can be anything as like GLTF or FBX or OBJ, like common model types. And then how you can then add some new objects and then save that to your resources folder so you can then perform the experiment. So I'm going to jump over to, this is the program where you can build your scene. So this is a model that I got off of Sketchfab, which is a pretty useful 3D model content library. If you're not familiar with it, they have over 150,000 Creative Commons free models that you could download and use, or you could bring us out of a 3D modeling program or various other sources. And as I said, you can also bring in 360 videos or images. And so the first thing I'm going to do is I'm going to go up here to File, Add, and I'm going to bring in just a few objects that we're going to collect data on. So I'll bring in this box here, and now just like with most 3D editing programs, if you're familiar with them, there's the transform tools up here, so you can translate, move the object around, you can rotate it or resize it. So I'm just going to kind of roughly just bring this over to the other side here, and then I'm now adding a second object. Let's see, I'll bring in a crate. So this one actually, again, I'm going to resize a little bit. So I'm just going to use the scale tool and just kind of eyeball it down. You could put in more precise numbers here if you want. And then afterwards, if you have any questions on particular things that you're wanting to do with this, just feel free to ask us, and we can either answer that in the webinar or in a follow-up. So I'll just rotate this. And then also, if you have like an object that's already in your environment that you want to use as something you're collecting data on, then what I should mention is, so there's a icon right here that you see above this tree of this model that's a group node. And so the way the eye tracking works now is it'll automatically, any object that has a group node will be something that you can potentially collect data on. And when you bring an object in, it'll automatically, it should add it as a group. If not, then you can go on the top of the tree here and go to right click and do insert group. And then the next thing you're going to want to do is also right click. You're going to want to rename this so that you can know what you're collecting data on. So this will save that to the data file. So I'm just going to rename these really quick. And then, as I said, if you click on an object in here, like this lamp, I just added a group node above the lamp so that I could collect data on that as well. And you can also, you could go in and you could create lights or backgrounds, but I'm just going to keep it pretty simple for now and just kind of keep it as that. And then what's pretty important now is you're going to want to save this. So in the eye tracking analytics lab, there's a if I go back to the root folder, there's a resources folder and then environment, and you're going to want to save this model that you're working on in that environment folder. And so now the next step is to go back, and then we're going to run the main script, and then you're going to want to have acknowledge running. So I have acknowledge running here so that I can send events to acknowledge. Hold on one second, let me check something. Oh, okay. And so I have acknowledge running here. So this is, I'm not wearing any physiological measurement device, but this right here is showing some sample EEG data that this could be from like a B alert or various devices that work with BioPack. And so this is just a sample data that I'm running here. And so now if I go back to the main folder, I'm just going to double click to run this script, the VR eye tracking lab. And so now we're going to be able to run our experiment. So the first thing I'm going to do is choose the hardware. So I could run this in desktop mode if I didn't have a headset to test with. Like this is a Vive Pro Eye, People Labs, the StarVR One, which I'm using, or the original Vive Tobii. Also, if you have a headset that doesn't have eye tracking, like the original Vive or an Oculus, you can choose that. And then it'll still collect data and analyze. You can review it just using head position. And so I'm going to choose StarVR One. And so now here, this is the configuration screen. So now here I can choose, if I click this, this will record a video of the experiment. This is if you want to be able to grab the objects that you've added. Here is where you can change the fixation threshold time. So you can, right now this is set at 500 milliseconds, meaning if you look at an object for more than 500 milliseconds, it'll collect that as you're fixating on the object. You can change the header hands of the avatar that you're using for the replay mode. And then here under environment, you have whatever models you've saved in that environment folder will show here, and then you click configure, and now you'll be able to choose which objects you want to collect fixations, and also whether you want them to be visible or not visible. And you could choose the model for the gaze point, intersect, or go back to default settings. And then once you configure this, this should automatically be filled with the settings that you chose the next time that you run it. And so now I'm going to click continue. And then the first thing I'm going to do is I'm going to actually calibrate so that this will be working correctly with my position of my eyes. So I'm just going to click C, and then I'm going to do a 5-point calibration. So I'm just following that point with my eyes. This could be a 3, 5, or 9-point calibration with the Tobii integration. Okay, so that's calibrated. And now I'll just put in my username and ID, which the ID you're going to need for replaying the mode, doing the session replay later. So I'm just going to put session ID. And now when I press spacebar, it automatically will start the acknowledge software. And now it'll in real time show as I'm looking around and fixating on these objects, or if I look at this crate or look over at the lamp for more than 500 milliseconds. The box. And so that green ball you're seeing, that's obviously the gaze intersect point. So that's the point between my two pupils where I'm looking. This by default is set so that the participant won't see this, but you can toggle that on or off if you want the participant to see it. Otherwise, it's just on the mirrored view for the researcher to see this. And so now after I run this, I can go back and look at kind of that gaze, 3D gaze path visualization of where I looked around in the scene. And then it was showing collecting fixations with the timestamp. And now when I close this, it'll give you just a quick kind of review of which objects I was fixating on for more than 500 milliseconds, the total time and the average fixation time. And then you can also see here in acknowledge, this is putting event markers that'll synchronize with the EEG or whatever data you're collecting. So when I fixated on the crate, then you could see what my EEG measurement was at that point. And you could change that in the code of how you want that to appear. And so now if I go back to this folder, so first now I have a video recording that I could review, and that has the timestamp. And so I could go back now into the data folder, which actually I was going to show that first. So there's the tracking data file. And so this has the timestamp with the XYZ position of the gaze point, and then you have the pupil diameter for each point. And then you also have a flag, like a custom flag that you could set. And this could be set to whatever you want it to be. Right now I'm just setting it so that when I fixate on this object. And so I could go back and see, for instance, at 15.41 seconds, or here when I'm looking at the crate, 14.68 seconds, if I want to see maybe what my pupil diameter was at that point. And I could see it was right here at about 4.07. And you could also export this as a CSV file if you want to be able to go and maybe collect an average pupil diameter, or kind of get different ways that you can further analyze this as a CSV file. And then you have this file, which also again gives you the summary of the fixations and then a timeline of when the first object was that you fixated on, and then each object consecutively after that. And now the next thing I'm going to show is actually a way that you could replay this now in 3D. And this could be viewed in a headset. By default, it'll be on desktop mode. And so now here, I could replay this with my little avatar I have here for my head. And this here I could show, I could choose whether I want to have the visualization be drawn dynamically, which is the way it'll be by default, so that it's showing that as I'm looking around. Or if I set it to static, then it'll just show it all at once. And then I could pause this and I could look around, or if I was wearing a headset, I could walk around and view someone who was doing this experiment. And so now I could continue to play that, or I could scrub through using the C and V file keys if I want to just fast forward. And here those fixation spheres are when you look at an object for a certain amount of time past that threshold, it'll start to build up a different color based off of like whether you're looking at each object for a certain amount of time. I'm not sure what that noise is. And I could restart this. I guess give me 1 second. I don't know what that noise going on is. And then if I want to hide this panel or show it, or also toggle any of the visibility of any of these objects. Okay, I guess that stopped. I don't know what that was. So that's basically showing the way that you could look at 3D models. The next thing I'm going to show is just a 360 video and how you can kind of use that in a similar way where you could view what you're looking at and kind of collect some fixations. So I'm just starting up this. One second. And I'll just enter another ID number. And so now this also is running acknowledge, and so now I could look around, and that's me opening up one of our viz boxes. So if I look at the viz box for more than 500 milliseconds, or look over at myself installing that, or just look around the room, now I can see that same 3D gaze path visualization. And then as you can see also in acknowledge, it was dropping events again to see whatever physiological measurement measuring and what my what it was at that point. And now you can also see the data of that I was looking at the Viz box. I fixated for more than 500 milliseconds on that for 3 times. And so you get that information. And the last thing I'm going to show really quick is just a heat map, which is right now that's set up a little differently. So you just run 3 different scripts. And there goes that sound again. I think my computer is about to explode. So I'm looking around here really quick, and this will generate a heat map. And so now I just comment out and just run the second script before the computer blows up. So this is generating the heat map. And then the last script, I'll just be able to view that and kind of change the intensity of the heat map. And so now I could just change the kind of size of that. And so, yeah, that's basically just a kind of general overview of, and some of that what I was showing is with the alpha version, like the session replay and the GUI-based setup. And then also you could go in, and if you want to modify the code, you could go into certain functions, like for instance, on gaze time, when you fixate on an object, you could have something happen. If you wanted to do like a gaze-based interaction, then you would add it to the gaze time function here, and that's where I have the biopack code being added, but you can customize that. And then also I want to mention that this is, you can also use a multi-user version, and so that has some different functionality. And you can also add additional hardware to it if you wanted to add data gloves or different types of hardware. Since it's set up with our VizConnect GUI, then it's pretty easy to add hardware in. I guess I'll hand it over to Dan and see if my computer's on fire. I don't know. So back to Dan.
Thank you, Sato. Yeah, I think I know some of that sound is actually one of the recordings that we use in our 360 video was recorded in a warehouse, and there's actually the sound of forklift operators in the background, so I think that was part of it. So let me go ahead and show my screen here, and we're in the midst of doing our live Q&A on the back end here. So we'll try and get through all of these, and really thank you guys so much for all the great questions that we've gotten so far. And I know Andy's going to speak to the first one as our chief scientist. I think that's the most appropriate. Maybe what I could do is just really quickly speak to the second question, which is how compatible are these headsets with consumer EEG headbands? So Sato and I have actually been working with an FNIR device to go across the forehead. And the FNIR device is going to give you it's a very similar situation where you've got the headband there. And with the Vive Pro Eye in particular, and I could pull that picture up again, but it's going to have to scroll through the whole presentation. But with the Vive Pro Eye, it's got this really nice kind of adjustable headband that can sit pretty well over the user's head. So I think it's really comfortable, and you can actually fit like a cap or a headband underneath that. So we have some videos. I think even on our booth for Neuroscience, there's a quick shot of Sato wearing a portable EEG, which is a pretty chunky piece of hardware, and he's actually got the headset sitting on top of that. So it's definitely possible. I think it'll be interesting to do some kind of like user studies of how folks are how much time can they spend in these. For us, we've been doing VR a lot just personally, and it's probably not a good idea to be in a VR headset for more than 20-30 minutes, just as a general rule, although you certainly can push it far beyond that, and I certainly have. But just something to keep in mind. We had this question about web bindings, and I didn't actually, so I did ask for some clarification there, so I'm just going to have to leave that for now. Maybe we'll follow up in email. But the next question about the Varjo and the Reverb. So we've been working with the HP Reverb for quite a while. The whole Windows mixed reality headsets. Some of them are really great. Sato, Andy would know a little bit better than I would. We do in fact have support for the Varjo at this time, although I believe the eye tracking functionality of the Varjo is something that we're working on at the moment. So we'll have to check back in if you've got a specific, if you want to try our visitor program with the Varjo, let us know, or if you've already got a reverb, you know, it's a great candidate, I think, for the pupil labs. But I could be wrong there. So just maybe follow up on email with a little bit more information. Andy, is this a good time for you to kind of take back over and answer this question about latency?
Yeah, sure.
Okay.
I think the citation that the attendee is citing is going to be the likely range. I don't have any better, more definitive answers from any of the manufacturers. If you just do the math of the fastest you could achieve on like an 80 hertz headset, so 2 times 1/80 plus, and then the fastest you can achieve with a 200 hertz eye tracker, that would be another 3 times 1/200. That's 40 milliseconds. So like really the theoretical bottom you're going to get right now on today's technology is 40 milliseconds, and that's assuming everything is done right and you're not making any additional processing steps. So it's easy to do things wrong. It's easy to not have hardware talking to each other, or the drivers to not be tuned right. So unfortunately, it'd be easy to go up to the 80 or worse. That said, this end-to-end latency, or what people often refer to as motion to photon latency in displays, 80 milliseconds is awfully good for a lot of tasks, but certainly not if you're trying to get into something really hardcore with, say, looking at eye motions or saccades, things like that. That's going to need higher, lower latency rather. So I don't have a more definitive answer there. Back to you, Dan.
Oh yeah, thanks, Andy. I think Sato would actually be the best to answer these next couple questions if he's still available in terms of the 5-point calibration. I can say for the StarVR, this final question on the page here, the eye tracker working with prescription glasses, as you can see, I wear prescription glasses myself. The displays like VR headsets in general, you can kind of, and it actually helps a lot for me to have my glasses under the display to create a clear image. But I'm not sure that it would be a good idea to use that with a eye tracking device, since you are having cameras. Oh, go ahead, Sato. Yeah.
With the glasses, there's sometimes a bit of reflection with the eye tracking, so the infrared light will bounce off of the glasses, so it's not going to give you as accurate of results. It might throw off the data.
But for just the experience of using a VR headset, then the glasses are fine. But the
I mean the StarVR or any HMD can be used with glasses. I mean, you just have to put it on in a way that you're not obviously going to crush your glasses or anything, but those definitely would work with glasses just as a display.
And then Sato, can you see these other questions that have been asked here about the 5-point calibration and things like that?
Yeah, I mean, I think to go into verifying calibration, there's information you could find online in that, or we could follow up. I mean, you could do, obviously a 9-point calibration is going to be more accurate as far as knowing where your pupils are located at, but that's something, I guess, as far as ways that people have been able to verify the calibration. They're with the headsets, like the Vive Pro Eye, for instance, the calibration is done in SteamVR. So there's not a way to go in and get further kind of deeper into the calibration over what they offer with the SteamVR layer. Maybe with Toby, I guess it's something we would have to follow up as ways that researchers are verifying the calibration. And I could say with the, there's a question on the Muse, that's the EEG device. I know that actually does work with our software. We have a researcher that's using that with our software, and he does use that under headsets because it's a very light form factor for an EEG device, and so that will work with headsets as well.
Awesome. And Sato, do you mind speaking to this other question, fixations in the gaze cursor? I'm not sure if you've got an answer for that off the top of your head here.
Yeah, so right now, I mean, it's more of a dwell time that it's using the intersect of the gaze point, the gaze intersect point intersecting with the objects and dwelling there for more than 500 milliseconds. As far as fixation, where it's staying within a certain range of velocity for a time, that's another type of metric that we're looking to add in the future. Right now, it's that you dwell in that intersect with the object with your gaze point for more than 500 milliseconds, or whatever you define as the threshold for your fixation. And yeah, then the question on pupil diameter. So you can do, I mean, I guess you could find a baseline. So there's a researcher, I think she might actually be on this webinar right now too, where they first had to establish a baseline off of different levels of brightness in the scene to kind of see what someone's baseline pupil diameter would be, to look for what would be more interesting results. People have used pupil diameter as a measure of interest when you're looking around and maybe your pupil diameter dilates, maybe you're more interested in what you're seeing, but then you are correct in that it will be thrown off by the brightness in the scene because you're going to react to that with your pupils as well. So it's just one metric that's available that we're showing kind of, but you can also use different metrics that you can add as well.
Yeah, and I think we're getting a ton of questions, so thank you so much, Seda, for jumping in there and answering those. And obviously, if you guys have any follow-up questions, we can also address them via email. I think we're getting a few more questions. I know if you see me looking down, speaking of eye tracking, it's because I'm looking at my phone to make sure that we're on top of all of these questions that have been coming in. So I believe a new slide was added just to cover a couple more of these. So I haven't seen these yet, so I'll have to take a second just to read through. Can we record a real 3D point of regard based on vergence? So Seda, I think this is something that you might have to respond to as well, if that's all right.
Yeah, I mean, I think that's something I'll have to talk with the person that's developing this right now. I think they are working on that type of detection of where you're looking the scene. So it's not just the line that's being drawn from your head point to where it intersects with an object in the room, but you want to know as your pupils converge at a specific point in 3D space. I think that's something that we'll have to get back to you on, but that is something we're looking into as well as adding that.
Yeah, the hardware certainly, this Andy, the hardware certainly supports that because you get eye direction from both eyes. We've seen users use that data to detect vergence and to get that what this attendee calls a real 3D point. I've seen it used effectively and for certain cases, and others where it's just too noisy. So it looks promising, and I think it's worth being added to our toolkit and made available for scientists to evaluate.
Yeah, that's another thing I wanted to add too, is that right now we are very interested in looking at what metrics people want to add, and those are things that we can look into developing and adding. So that's why we'd be interested in having people test us out and kind of give their feedback on what things they want to see. And these are all things that we're actively adding to our application as well.
Okay, perfect. Well, I think just to speak to these last two really quickly, and we'll follow up in a little bit more detail. The possibility to use this software on online VR platforms. So right now, this is really kind of a based in our virtual reality development tool, which is called Vizard. So it's not really compatible with, WebVR or any of these types of online applications. It's really for research-specific use cases. But you are able to bring in assets from other engines like Unity or Unreal into the Vizard environment. So there will be a little bit of reconfiguring, but it should be, giving you a big head start in terms of developing an environment. So if you're interested in trying it out, let us know and we'll definitely help you out. This final question about 360 camera, that's definitely what we would recommend. It's pretty cool with a 360 degree bubble, basically. The heat map is going to be the easiest way to do an evaluation of a 360 video, but there are some kind of tricks that we've been developing to kind of place virtual objects in the 360 environment so you can actually tag effectively what the objects might be. So if you're interested in using 360 video, let us know. I think we're just about at our hour point here, so I think we'll be wrapping it up. But there's going to be a survey that's going out shortly, and then if you guys can just let us know in the survey what you thought of this webinar, any additional questions you have. We definitely follow up with all of our attendees for these webinars. We're really happy that you all came and joined us. If you have any questions, you can reach us directly at sales@worldviz.com. There's going to go to definitely a few people who will be able to respond to any question you have. We also have our YouTube channel, which has all of our old webinars from this past year of kind of being in lockdown, and we've had some pretty fun topics like if you're interested in hardware, we do a lot of deep dives on hardware and pricing for hardware and how to spec out a lab and things like that. So there's a whole bunch of really cool content on our YouTube page. And then also, if you're just looking at the kind of things that we do, worldviz.com is where you can go and download the free version of Vizard, our demo launcher, which has the walk the plank demo that I mentioned, some other things, and then just a ton of resources for folks who are looking to learn more about VR or develop some new experimental protocols. So thank you all to everyone who came through from Neuroscience, and thank you all to all the folks who joined us from our newsletter group. Looking forward to seeing you again. And if you have any ideas for what you'd like to see covered in future webinars, feel free to let us know that as well. So thanks again so much for joining us, and look forward to seeing you next time.